So it's left with one line. I'm finding it difficult adding. It's not giving me the option. Okay, let me do it this way. Oh, sorry. Okay. Okay, so let's start with the figures. 2009 was
22.
22,
24.
24,
29.
29,
38.
38,
36.
36,
31.
31,
40.
47. Like this, right? With the same instruction, isn't it?
Yes, sir.
Yes, sir.
Okay. So we'll work it out and then you mark yourself. No cheating. This was for you to try your hands on it. So we'll use how do you call it? I'm going to use ChatGPT to do that. I hope we all have accounts.
Yes, sir.
Do we all have accounts? I want to demonstrate how you can use the ChatGPT or the AI to also do the prediction or the regression calculation. So that's the main platform that we've been asked to use according to the syllabus. Now, this is how you go about it. You want to work out something here. You either attach it by going here, the plus sign you see here. Can you see my cursor?
Yes, please.
Yes. So you click on this, add photo of files. Then you go and pick the file you want to attach. And then you issue the command, or what we call the prompt. And in this case, we have it here. So I'll just copy it from here, like this. then come and paste it. The large language model understands images. It can interpret images, can interpret words, figures. So whether the document is in a form of image, is in a form of Word, Excel, PDF, or any other file, it is able to read and understand. So now that I've attached this, I'm now going to copy the instruction that says find the linear trend through the method of least square and forecast the sales for the next 2 years. So I'll copy that, then come here and paste as the instruction. So now I can say execute, or you can enter. Let's see what it's going to do. See, started by saying analyzing the image. This is what goes on behind. I might use Python. With sales data from 2009 to 2015, I'll calculate using the method of least square. Now let me compute the trend. Computing linear trend for sales data. You see all the methods that we went through. You see it is doing that. You see it's calculating the S values. Do you remember how we did it?
Yes, sir.
Summation S will always be equal to what?
Negative, negative,
Zero.
0, positive, positive. So it should be equal to 0.
Summation X should always be equal to what? 0.
Zero.
As we did the last time. Now with the sales, we have these values. 22, 24, 29, 38, 36, 31, and 40. Say step 1, prepare the working table. You did it, isn't it? The last time.
Yes. Yes, sir.
The year, the sales, then we calculated the x multiplied by y, and x squared. Hope you can see that.
Yes.
Yes, sir.
Right. Let me collapse it so that see it. So did we get this right? Let's cross check with our
Yes, sir.
figures.
Yes.
Right.
Yeah.
Who didn't get it right? Be sincere.
So we got this right.
You or we.
Got it right.
I got it right.
Well, you can't speak for the others. Nobody is talking apart from her.
So I got it right too. I also
No,
got it
okay.
right.
You.
I've also gotten it correct, sir.
Okay. There is an Akan saying or proverb that goes like this. Echun ruha yempam ne damta. If umami will now so ada exams day we shall see. So now the second step, it is doing it step by step as we started. Find the trend equation. The least square trend is always given as what? Y equal to A plus BX.
Yes, sir.
Where A is summation Y over what? N.
And
The formula we proved or we derived. You see it? Then the
yes, sir.
B is summation XY over summation X. And these are the answers. So the linear trend equation then becomes YC being equal to the A, which is what? The 31.43 plus the B, which is what? 2.68 multiplied by X. So wherever you see X, you slot in the X figures and calculate the prediction for each year, right? We did it
Yes.
manually.
Yeah.
So you can see the summation of X giving us the 0.
0.
Yes. All right. So, we use YT, where T represented what? The
The year.
year. And it is using what? C.
Mm.
So it means the same thing. So year 2016 is the predicted sales. And X for 2016 was 4. Let's see if it is true. Oh, okay. It is, sorry. It is doing the prediction for next distance, for the next 2 years, rather.
2 years.
Yeah. So 2016 is the one we are predicting. That's why it is putting the figures there. So how do we get that? Who can tell me why it got 4
The
for
4,
2016?
finding the X, the 4 is for the year 2016, and then it is T minus A, A being the artificial.
I'm not hearing you well. Can you speak and
Yes, sir.
speak up? Yeah.
Yes, please. Finding the X for 2016 will be
Mm-hmm.
T minus A, and then the T is the year, and then the A will be the artificial average. So, and the mean
And
for
what was
it
the
is
artificial average?
2012. 2012.
2012.
Yes, 2012. So it will be 2016 minus 2012, giving us 4.
Okay, great.
Yes.
The
So that's why we
same
have the science.
was used for 2017, right?
Yes.
Yes, sir.
So these are the values for what? 2016 and 2017. So the final answer, the linear trend then becomes this. Yes. So forecast sales for the next 2 years will give us 42.15 thousand, and 2017 will be 44.83 thousand. Remember, the figures are in thousands. Yes. Rounded to a whole thousand of 42,000 and 45,000. So this is what you were supposed to get. Did anyone got somewhere wrong? Or you all got it right?
We all got it right.
Yes,
So
sir. We got it.
if I ask you to show work, I sure will see what you are saying.
Yes, sir.
Yes, sir.
Okay. Very confident. That's a good sign, meaning you understood everything we did the last time, isn't it?
We
Yes,
did.
sir.
Yes, sir.
Now, there is also an Excel means of calculating, or how do you call it? Calculating regression. Okay. These are the figures, isn't it?
Yes.
The Excel will not give you explicit as the AI gave. To give you, it will do proper data analysis. And you must understand what it means and what it stands for. So if you want to do regression analysis using the Excel, here's how you go about it. You go to data. Are we following the process?
Yes, sir.
Yes, sir.
The first you click on is hello.
Hi.
If we are at home like this, we are going to work with what? Data,
Data.
isn't it? So you click on data icon, the one here. Can you see my cursor?
Yes, please.
So click on it. And when you click on it, search for data analysis. Mine is somewhere here. That's the data analysis tool. Can you see it?
Yes.
So you click on data analysis tool. And all these are data analysis tools. You can see them here. ANOVA, single factor. ANOVA simply means analysis of variances. We have two-factor analysis. Okay. And even the two-factor, we have the two-factor with replication and without replication. We have correlation analysis, covariance, descriptive statistics, exponential smoothing, F-test, to sample for variances. Whole lot of that. See, even histogram is there. Moving average, random number generation, rank and percentiles. We have regression, sampling, t-test, and all that. A lot of them. So, depending on what you want to do, if it is a correlation you are looking at, you just go and click on correlation. If it is regression, you click on it. If it is histogram you want to draw, you click on histogram. So we are interested in what? Regression. That's why I have clicked here. And then you do OK. Okay. So now, when you do this, the last time I was plotting on the board, I said we always have the Y and X axis. What noise is that? Is someone washing something? Anyway, so this is the Y input. So in your opinion, the X and Y axis, which one should go on the X axis and which one should go on the Y axis? What are we predicting in the first place?
We are predicting Y.
Great. So the one you're predicting should always be on the Y axis. That's why it is called Y. Do you get it?
Yes, sir.
It's not called Y for nothing. It is called Y because that is what you are predicting. And on the Cartesian plane, or the X and Y axis, the predicted values are always found on the Y-axis. Hence, the reason we call that Y. So let's now select the Y values here and the X values here. So the year will be the X. So the year will be here. You see that is set from A 1 up to A8. So you can see that. That's what is selected. Now, the cells which is being also come to the y-axis. Now, do you want to see labels? Yes, we want the labels to show. We are looking at confidence level. The standard one is 95% confidence level, and it's there already. Unless you want to change, so it's there, it's embedded. You can change it if you want to be 99 or you want it to be 90. Other than that, it is always default 95%. If you want to see residuals, you can take this. If you want to see a plot, you can take this. If you want to see standard residuals, you can take that. So depending on what you want to see, then you tick. I want a line fit, so it's ticked. And then normal probability plot. You want to see that one too. So you tick that. If you don't want it, you untick. When you are done like this, you click OK. So this is the results. If you have ever looked at published papers that uses, the authors used regression, you see all this, the ANOVA table, and then the regression statistics here. Then you have the coefficient table. For this coefficient, so that tells you the coefficients of all the variables in it. Now, this one, let me try to reduce the decimal places. Sorry. So in the AI, what were the values for the predictor values? Let me see whether we have the same thing. So these were the original values. Here, isn't it?
Yes, sir.
And these are the predictor values. That's what we got. May cross-check.
Yes, please.
Yes, it's the
When
same.
you round it up, the
When
same
you're
numbers.
here, it's the same numbers.
So this is how SL2 is used. Now, you can derive your regression equation from here. Okay? From this. This is the intercept. That is the A, the value here. When you come to this regression statistics, what it means is that we always use the R squared to determine the fitness of the model that you are using. So when we say R squared, that is what it's used for. That is the essence of it. So the fitness or the correctness, if I should put it that way, of the model is always measured with the R square. What it means is that the regression equation you are using in the prediction, is it accurate, or is it better, or is it good enough to use for the prediction? And this can be determined using the R square or the adjusted R square. So let's look at the R square here. It's 0.698. When you approximate, that would be 0.70, right?
Yes.
This simply means that the sales that we are using or predicting, the sales values contribute 70% of the change. Meaning sales play a crucial role, and it makes it very fit for others to even use the model we are using to also replicate similar research or similar analysis. So in research, we use this to determine the fitness of the model you are using. Model here means the number of variables that you included in the mathematical formula we are using. That makes it a model. So if you are looking at, let's say, promotion, you are looking at TV and radio advertisement, you are looking at discount and all that. All put together makes the model great, and that it is about 70% correct or fit. That is what it means. So that is how you can also use, how do you call it? The Excel to do regression analysis. Now, all this we here, we actually said we needed the number probability plot. We ticked it. That is why you can see it. Yes. And this is the line of fit. The line of fit, if you are plotting the sales against the year, this is how you get it. So you can draw a straight line through the middle. You want to see whether the variables are normally distributed. Because in a regression, one of the assumptions is that before you can use a particular data for regression analysis, the data set you are having should be normally distributed. Meaning, if you plot a straight line among the dots that you have plotted, they shouldn't fall far away from the line. And as you can see, the blue things are the line. They are not falling far away from. Any questions so far? Hello?
No, sir.
No, sir, from my side.
Okay. So we now know how to go about doing analysis on the AI platform. Just upload your data and issue the command or the prompt. It's going to do it for you. But mind you, if your prompt or the command I'm talking about is not well structured for the AI to understand what you mean, you may not get the right results. Assuming it wasn't an exercise form, and you were to write what you wanted it to do for you, this thing we are seeing here should have been typed by you, and it should have been able to state it clear like this for the AI to understand. Because the AI is mimicking the human intelligence. And for that matter, the same way if I tell you something and you don't get it, you may assume that I said this, which may probably not be what I said. So you end up doing a different thing. So there shouldn't be ambiguity in your prompt. If you're writing something for the AI, it should be clear. It should be clearly stated. The clarity should be there, such that if anybody comes to read what you have written, the person should not ask you any question. The person should understand it straight away. If you make a mistake, the AI will make a mistake. So you don't blame the AI, you have to blame yourself because you don't know how to communicate with the AI. We didn't write because we had the instruction stated already. That is why I copied and came and pasted it. So let's now proceed. So, sorry. I think we said basically in prediction we have two main modes of predicting. Can you remember the two main modes or types?
Yes.
Please, let's hear you.
Regression.
And
Classification.
you are speaking up your voice, okay? So that I can hear what you're saying. Say regression and what?
Classification.
Great. So last week was regression, and today we are going to talk about the classification model too. How we can use the classification model for business decisions. So this is what we hope to achieve. We have to understand the classification models properly, interpret what we call the confusion matrix. So Rafina, did you hear that? Philip,
Yes, sir.
did you hear the meaning, the word confusion what?
Matrix.
So clear your mind, don't come and confuse yourself.
Yes, sir.
You should calculate the key metrics. there are some metrics that you can use in calculating the confusion metric. When we say metrics, we simply mean the formula or for calculating something. Understand business trade-offs and apply classification to real problems. So let's start. Last week, we learned about regression that predicts what? Continuous values. And we learned that models use features to predict the outcome. And we talk about features, we mean the variables you are considering. We want to predict sales. What and what should we be looking at that affects sales? This becomes what? The features. So for instance, if we are trying to have a discount for our product, and as a result, sales was boosted, then it means the feature here is the discount. And the outcome is the sales. We learned about that. Then coefficients also show what we call the impact of the variables or the features on the model. Remember, I said that if we have 20 multiplied by discount, the 20 behind the discount becomes the coefficient of the discount. So whatever figure the discount is, we multiply it by the 20, and the 20 becomes the coefficient. We also learned that models support business decisions. For instance, the one we just finished solving by predicting 2017, 2018. It will tell you that going into the future, this is how much sales we are expecting. And that should influence the decisions you have to take going into the new year. So the key question I want to ask is, what type of model predict categories instead of numbers? Are we there?
Yes, sir. Classification model.
Great. So in transitioning from the regression to classification model, we are now moving from how much will happen, or how much, because in the regression model, we are able to calculate the coefficient and know how much each of the features affect the model. But in classification, that is not what we look at. We always look at, will it happen or not? So regression talk about the quantum of impact or effect of a particular feature or variable on the outcome. The outcome, I said, is what we are predicting. And in classification, we are looking at the possibility of it happening or not, without looking at the impact or the effect, the actual quantum of the effect of that particular feature on the model. That's not what we are looking at. We are only concerned here is whether it is no or yes. Is it going to happen or not? Are we clear?
Yes, sir.
Someone said I was fast the last time. Was it Seraphine? Or who was that? Am I being fast again?
No, the pace is okay.
All right. So let's look at this example. Will a customer leave? So you want to predict whether your customers are going to leave or not. As to how many customers will leave, you cannot determine with this type of model, the classification model. Your concern is whether a particular customer will leave or not based on certain features. For instance, the customer has been giving feedback that your front desks are disrespectful. Anytime the customer makes a pitches and you send the person to review his or her experience, then the person writes, your front desks are not up to task. They are disrespectful. This is a sign that should let you be alarmed that if you don't address that issue, that particular customer giving you that complaint or that feedback will one day leave and not come back. After all, you are not the only person who offer that particular product. Will a loan default? Is this fraud? So this is yes or no thing. So classification is always about whether it will happen or not. Will a student pass? How will you know this? Based on certain features. Why classification matters in business? Classification helps businesses to detect fraud, reduce customer churn, or what we call customer attrition, approve or reject loans, identify risky transactions. That's what classification does. Predict students' performance. So let's look at this quick exercise. Identify which are classification problems. Are we good to go?
Yes, sir.
Yes.
Yes, sir.
No, okay.
Yeah.
So one, predict customer churn. Yes or no?
Yes, clarification.
Lamte, are you there?
Yes, I'm here.
Okay. Predict monthly revenue. Is it a classification or not? Yes or no?
Classification.
No.
Not a classification.
No.
What is it?
It's a regression.
No.
It's a regression. Detect fraud. Fraud or not fraud. So is this also a classification or
Yes.
Yes,
Yes.
regression?
classification.
Yes, sir. Classification.
Predict delivery time.
Regression.
Regression. Great. So these are our answers against what we said. I hope we got all right.
Yeah.
So today, this is what we'll be looking at. We understand classification, confusion matrix and metrics, precision, recall, F1 score, and ROC. ROC simply stands for Receiver Operating Characteristics. Receiver Operating Characteristics. Then thresholds and trade-offs. Then we'll be doing some hands-on practice. Understanding classification in businesses. Classification is used to predict categories or classes. For instance, yes or no, fraud or not fraud, approve or deny, pass or fail. That is classification. We don't care about how many pass or how many failed. No. We just want to see groupings of failed students against past students. So the simple definition for classification can be this. Classification predicts which group something belongs to. Business thinking behind classification. What do you think are the thinking behind this classification model? Can someone guess? Any?
Say, can you say for feedback purposes?
For feedback purposes. Okay.
To help with decision making.
To help in decision making. What again? So we shall see whether we are right or not. Businesses ask questions like, will this customer churn? Or will this customer leave? Will this transaction be a fraudulent one? Should we approve this loan? Will a student pass or fail? We must also know that we have two types of classification models. When you look at this one, will this customer churn? The outcome will be what? A yes or no, isn't it?
Yes, sir.
Will this transaction be fraud? That will be fraud or not fraud, isn't it? Should we approve this loan? That is yes or no, isn't it?
Sir.
Yes. So these are just two answers each that we can give. But in classification, we have the two answers one or the two outcomes. And we have the multi-class one or the one that you have to different groupings, more than the two groupings. So the one with just two outcomes, no or yes, fraud or not fraud, is classified as binary. Binary means two. And a multi-class classification, you have more than 2 outcomes. For instance, you are talking about grade. You can have grade A, grade B, grade C. If you are talking about product categories, you can have different product categories. If you are talking about, let's say, Toyota cars, do you know the number of brands that we can get out of that? That is multi-class classification. Are we good to go?
Yes, sir.
Yes, sir.
Yes, sir.
All right, so let's look at this data set. We are considering customer attrition or churn. So these are customer spend, customer complaint, and the churn. A customer who spent 45 cedis complain once. What is the churn rate? Say no. 70 complain twice. The churn rate is yes. 60 twice. Churn rate is yes. 50 is 0. So that complaint means the person is satisfied, isn't it?
Yes, sir.
Hello? Yeah,
Yes, sir.
great. So meaning that attrition will be no. The person is not likely to leave. For the customer who spent 80, the complaint was what? 4. And meaning the person is not satisfied. That person is likely to leave. So it's a yes. If you look through this data set, you realize that those who spend more complain more. 60, 70, 80, they all complain. And 45 only complain once. So looking at this data, what is the target variable and what are the features?
Target variable is the churn.
Great. And the feature is?
The complaints.
Great.
Customer spend.
So this is the answer, the complaint, and then what? The expenditure of the customer. Yes. So from what we just observed, that is from the data set we just observed, high complaints mean likely what? Churn. Those who complain are very low are likely to stay. The implication is simple. This simply means that if the person does not complain, it means the person is satisfied with whatever service or product you are rendering. Higher spend customers may churn if dissatisfied. So complaint strongly does what? Influence churn. That is what we just observed. So let's look at some simple classification logics. This is a rule that you can input in an Excel to be able to do that classification predictions for you. If complaint is greater than or equal to 2, The prediction is what? Churn. Predicted churn is what? Yes. If it is complaint is less than 2, it predict churn is no. We observed that complaints strongly influence what? Churn. So this simply means that anybody who complains from 2 upwards is likely to leave, meaning they are not satisfied. Anyone who complains lesser than 2, that is 1 or no complaint at all, is likely to stay. So this is a simple decision rule we can input in Excel to sort out data for us. So using this rule, if complaint is greater than or equal to 2, it predicts churn as what? Yes. So let's do the prediction. The first one complaint, what will be the answer?
No churn.
That would be
Pardon?
No.
no.
No. 3.
Yes.
0.
No.
2.
Yes.
Yes.
Great. Those who didn't contribute, are you with them or you are lost?
They are with them.
Okay. I'm glad you all understand what we are doing. So this is the answers. And I think we got all right, isn't it?
Yes.
So from what we just did, customers with more complaints are at risk of leaving. Business should therefore focus on customer satisfaction. And what are the actions that you can put in place or implement to improve customer satisfaction? 1, you have to improve customer service, resolve complaints quickly, and target high-risk customers, and have one-on-one with them to pour out all their dissatisfaction, and you will then find a way of resolving them so that they can be at peace and not leave. So this gives us something to put in our pocket. In our private businesses, if whatever you are doing, whether you are selling something or you are rendering any service, and you employ some staff or some workers for yourself, and these workers are not offering good customer service, then it means your business is going to collapse one day. There is one thing establishing the business, and there is one thing sustaining it. And this has made us to understand that poor customer service can easily make your loyal customers leave you and go to your competitor. So in Excel, if you want to do a calculation, this is the rule. you create what we call if statement. So for instance, if complaint is greater than or equal to 2, then it means the chance rate is yes, otherwise it's no. And the output is that it's going to predict all the chance values for you. In Python, this is this thing you are going to use, the coding you are going to use. I want us to try this particular if command and see. Okay, so this is what I did. This is the prediction. And this is the complaint. Okay, we want to see whether the customers are likely to leave or stay. Okay. So look at it. If this one is what we are talking about. If A2 is equal to 2, then it's yes, otherwise it's no. So A, this is the A, and this is the 2. So that's the formula in here that was used to drag this. Okay, so let's now do it afresh here. Sorry. Okay, so if you put it here and you write equal to if, you see the if function. Have you seen it highlighted?
Yes.
Yes. So we are saying that if complaint, sorry, you have to bring a bracket. Yeah, if complaint is equal to, is equal to, let's say 2 or more, isn't it?
Yeah.
Is equal to 2. If we leave it this way, what will happen is that anything that is not 2, it will say no. Even if it is more than 2, if the complaints are more than 2, it is still going to say no. Unless you put or greater than. Okay?
Okay.
If you put just equal to, it's not going to give you the right prediction. Because anything more than 2 or less than 2 is not going to consider it. But we are looking at something that is equal to or more than 2. So we say should be yes. Other than that, we say is no. So it's true or false to know, yes or no. Now, this one is 1. So the customer churn, that's a false. What about here? This 3. For the customer churn, what do you think should be here? Is it true or false?
True.
Great. So let's drag and see if to give us true or false. Oh, I think we did. The formula was wrong. In Excel, this is what happens. If your formula is not right, you get it wrong. Okay. So now we have the no. So the customer churn, it should be yes. So is it now we have the right formula? If A2 is greater than or equal to 2, then the customer churn is true or false, or yes or no. So this is the prediction. So even without any sophisticated tool, with your ordinary Excel, you can use it for these predictions. Both the regression and the classification models. So let's cross-check and see whether what we have is correct. I'll come back to these two things and show you why some of them are not the same, especially this one. Let me clean this so that I will compare, especially this. This one is no, here is yes. Here is no, no, yes. So some are not corresponding. We'll get to that. I'll let you know why. The formula here and the formula here, there are differences, and that is why it's happening that way. So now let's concentrate on what we just did. The complaint was 1. Customer churn prediction. Is it going to be no or yes? Remember the rule is if it is 2 or more, isn't it?
Yes, sir.
The next one is 3. Will the customer go or not?
Yes.
This one is 0. Is it no or yes?
No.
This one is what? 2. It's a yes. 5 is a yes. 4 is what?
4 is a yes. Yes.
7, 8, 3 is a yes. 1 is a no. 1 is a no. 2 is a yes. 0 is a no. 2 is a yes. 0, no. 6 is a yes. Is it 6 is a yes here, but here it was no. You observe that?
Yes.
Yes. I'll let you know why. 0 is a no. 1 is a no. 0 is a no. 2 is a yes. So the reason why there is difference between these two predictions are that this one, we said A2 is greater than or equal to what? 2. And here, let me click here and you see the formula. We say A2 is equal to 2. If it is 2, it's yes. If it is not 2, it's no. So anything that is below or above 2, it will still give it what? A no. And that is why you can see from here that all this is giving it what? No.
No.
They are not equal to 2. that is what you have told it to do. I hope you get it.
Yeah.
We didn't say anything more than 2. We say when it is equal to 2. So when you are using the if command, what you should make sure is that the command you are giving is exactly what you want, you mean. So if I had just used this in any business prediction, it means everything I'm going to get is going to be wrong. Because that is not what I wanted. I wanted when complaints are 2 or more, and not just exactly 2. Can we make progress?
Yes, sir.
Okay. So that's how the if command is used. In Python, I said that one will not go to. So let's tackle this one, and then we'll bring the lesson to an end. The confusion matrix and evaluation matrix. Why evaluation matters at all? A classification model is not just about prediction. It must be evaluated correctly. So the question that comes to mind is, how do we know if our model is good? For the 2 examples I just showed you, you realize that one was wrong and one was right. How do we know that? The answer is to be able to know whether your classification model is correct. You use the confusion what? Matrix and metrics. Please don't get confused. So this is how it works. A confusion matrix shows how well a model performs. What does it do? It shows how well a model what? Performs. Are we good to go? Hello, are we there?
We are good to go, sir.
So from what we did, the prediction that we did, we're looking at a no or yes, isn't it?
Yes.
Yes. So if the actual thing we are expecting is yes, and our model predicted yes, we say that the prediction is a true positive. Before we even get that, let me ask this. Yes or no, which one is a positive answer and which one is a negative answer?
Yes is positive and no is negative.
Great. So we are expecting that because the actual thing we are seeing should be yes, if the model predicts the same yes, then it means it has predicted true. That's a true prediction. And it is in the positive way, isn't it?
Yes.
So if the actual is yes, and the model predicts yes, then that becomes what? A true positive. If the actual is no, and our model predicts yes, the yes is a positive response, isn't it?
Yes.
But in actual sense, it is wrong, isn't it?
Yeah.
Yes, sir.
Yes. Even though it is yes, which is a positive, the answer is false. So we say it is false positive. Are you getting the drift?
Yes, sir.
Great. So let's go to the next column. If the actual is yes and the prediction is no, the predicted answer we are getting from the model we are using says no, even though the actual is yes. The no is a negative response, isn't it?
Yeah.
And the answer it gave is also false because we're expecting what? Yes. But it gave us a false and a negative response. So it is false negative. Now, if the actual is no and the predicted is also no, no is a negative response, but the answer is true because we were expecting no and it gave us no. So it is called true negative. If I were you, I'll take a screenshot because we are going to use this logic in the subsequent slides. Can we make progress? So true positive implies that correctly predicted yes. True negative means correctly predicted no. False positive means wrongly predicted yes. False negative means mixed actual yes. So let's look at these examples below. It says that we are looking at fraud. Fraud correctly detected becomes a true positive prediction, isn't it? We are looking at whether it is fraud or not fraud, and it correctly predicted that it is fraud. It becomes a true positive, isn't it? Our friends, are you tired? Should we close?
So we are following.
And I ask and you don't answer. How do I know you are following? Now, normal transaction flagged as fraud. The last time I was giving an example that in banking, if anybody deposits 20,000 or more, it should be reported to the anti-money laundering headquarters. And I indicated that if someone is coming to open an account, they ask you how much turnover you expect, they should expect from you. So you may indicate that I will be able to deposit 100,000 Ghana cedis in a week. So they will put that in your form, on your form, and input into the system. So if you divide 100,000 by 5 days, what will be the answer?
To be 20,000 a day.
20,000 a day. Great.
Yes.
So assuming that somebody who deposited 20,000 a day and indicated that in a week you'll be able to deposit 100,000. Is that a fraud or not?
To be a normal transaction.
To be a normal transaction. But the system knows that anything from 20,000 above is fraud.
Okay.
Just like how we inputted into the Excel sheet. That is how we do those systems that we use. So we are saying that any deposit greater, equal to or greater than 20,000 flag as what? Fraud. So even though the person is doing a normal transaction that is within the turnover that was stated during the first day of account opening, the system is still going to what? Flag it as what? Fraud.
Fraud.
Okay.
Flagging it as fraud now makes it a positive thing, but it is false. So normal transaction flagged as fraud becomes what? False positive.
Okay.
Is it understood?
Yes, sir.
Yes, sir.
Now, when the fraud is missed, the thing is fraud, and it say it's not fraud. For instance, somebody who could only deposit 20,000 a week, 20,000 divided by 5 days will be what?
100,000.
Divide by 5 days.
Divide. That'll be 4,000.
So, such a person who say he could deposit 4,000 a day, and all of a sudden brings 30,000.
Hey.
Is that not a fraudulent thing that needs to be alarmed or flagged?
Yes,
Yes.
Yes. So in such a situation, if the system still misses that out and say it is not fraud, not fraud means it is what? Negative answer. And the answer is also a false answer. So it's false negative. Normal transaction correctly allowed. For instance, the 20,000 per day person, if it is not flagged, that is correctly what? Allowed. It becomes a true what? Negative. So if we are asked to fill in the matrix, can we do this? When I say the matrix, we are talking about the 4 thing, the 4 quadrants.
Okay.
So you have the actual yes, actual no, against predicted yes and predicted no.
yes, sir.
So let's fill in the confusion matrix. So let's do it this way. Take a picture of this so that we can relate with the next slide. Our time is up, but give me the next 5 minutes for us to finish this exercise.
Taking the picture.
Okay, so let's move ahead. So this is the confusion matrix. The first one, is we have the customers from A, B, C, D. The actual A is yes,
Yes.
predicted is yes.
Yes.
What does that become?
True.
True
Positive.
B, the actual is no, but it predicted Chan as yes. What is that?
False positive.
False positive.
Great. C, the actual is yes, and it predicted what? No.
False
True
negative.
negative.
Who
True
was
negative.
saying false? It's true negative.
True negative.
Yes. D, the answer is no, and it predicted what? No.
True negative.
False negative.
Hmm?
False negative.
So what's the difference between your C and D? The C, the actual we are expecting yes, and he said no.
Yeah.
So no means a negative response, isn't it?
Yes.
And the answer was also false, or it was right.
No.
So the C is false negative. Someone was about to say it and was not confident enough.
So he said it was for true positive.
No, someone was mentioning false and somebody said true positive. True negative also. So now D, choice and no, and predicted is no.
True negative.
Yes,
Negative.
this is rather the true negative one. The C is false negative. The D is true negative. So from the data set, we have true positive one, that is the A. False positive is also one, and that is what? The B. False negative is also one, and that is the C. And true negative is also one, and that is what? The D.
The D.
So this is how the confusion matrix is going to be. Sure, yes. Predicted yes is what? 1. That's the true positive. We have only one. And then the actual no, predicted yes, we have false positive, that is 1. Then if you come to false negative, we have 1, where actual is yes, but it predicted no. And then actual is no, and it predicted no, that is true negative, it's also 1. So this is the confusion matrix. I hope it is not confusing enough.
Yes, okay.
So based on that, we calculate what we call accuracy and recall an F1 score. Now that you are tired, I don't know if we have to finish this. I have to go through this small calculation, or we'll continue next time we meet, which is which. Let's agree. That will take about 4 slides.
Maybe we can finish up.
No. So it's about 5:22. Let's see by 5:30 if we are done. So let's do this. Let's take this picture too, especially the confusion matrix. Oh, sorry. Can we take this? Can we move forward?
Yes, sir.
Okay. So if we say these are the metrics that I talked about, we have the confusion matrix and metrics. These are the metrics. Metrics, I said they are formulas for calculating something. Now, the accuracy we are talking about measures how many predictions were correct. Okay?
Okay.
So based on the table, I just asked you to pick, take a picture of it. How many of the predictions do you think are correct there?
Two.
Say 2.
2. Great.
You are correct.
So the formula is this. Accuracy is equal to true positive plus 2 negative over the total number of outcomes. What is the total number?
4.
4.
We are looking at the A, B, C, D.
B, C,
They
D.
are 4, isn't it?
Yes, sir.
Yes.
Yes. So true positive, we had 1. True negative, we had 1. And the total is 4. So 1 plus 1 over 4 is what? 2 over 4. 2 over 4 is 0.5. 0.5
Yes.
multiplied by 100 will give you 50%, isn't it?
Yes, sir.
Yes, sir.
Did you get the mathematics?
Yes, please.
Okay. Now let's look at precision. It also measures of the predicted years that you had. How many were correct? You can have yes, but are wrong, isn't it?
Yes, sir.
So the formula says that true positive divided by true positive plus false positive. We are looking at the ones that are correct. And from the table, you took a picture. The true positives are how many there?
1.
And false positive are what? How many?
1.
1.
So it's going to be 1 divided by 1 plus 1. That is, the true positive is 1 divided by 1 true positive plus 1 false positive. That is going to be 1 over 2. And 1 over 2 is half. Half means 0.5. In percentage-wise, it is 50%. Precision is important for avoiding false alarms. So you want to know how the model is precise in its prediction. This is how to work it out. Then the next one is the recall. If we say recall, that matrix measures of the actual years that you have. How many did we detect? And the formula says true positive divided by true positive plus false negative. So from the table, the true positive we had 1, and false negative we had 1. So that is also going to give us 50%. The F1 score balances precision with recall. And the formula is 2 multiplied by precision plus, times recall over precision plus recall. I take it again. The F1 score that balances precision with recall is calculated as 2 multiplied by precision times recall over precision plus recall. And remember, we have calculated precision and recall. Recall we had 0.5, isn't it? Precision 2 we had 0.5. So going back with this figure, let's slot them into the formula. So we are going to have 2 multiplied by 0.5 times 0.5, isn't it? You can work it out on your table. 2 multiplied by precision, which was worked out to be 0.5, multiplied by recall, which was also the same value, 0.5. Then you divide by precision plus recall, and the precision 0.5 plus 0.5. So what was the outcome? Are you done calculating? Hello?
Just a moment.
Okay.
So I got
You got how much?
0.5.
You got 0.5. Who else got a different figure? Any different answer? Hello.
Say 1.5.
You got 1.5. Please work it out well. Let's do it together. Now, these are all 0.5 figures. So
Yes,
0.5 times 0.5 will give us what?
0.25.
0.25. Multiply by 2.
0.5.
You got 0.5. Divide by precision is 0.5 plus 0.5. 0.5 plus 0.5 will give us what?
1.
1.
So 0.5 divided by 1 is what?
0.5.
Yes. So 0.5 is the right answer. Is it okay?
Yes, sir.
Great. And there is also another metric called ROC, AUC. ROC simply means receiver operating characteristics. Receiver operating characteristics. AUC means area under the curve, nothing more. So it measures how well the model separates classes. For instance, if you have this range, 0.5 implies random, 1 implies perfect. That is class separation. So higher area under the curve is equal to better model. So this is the business interpretation of the metrics we've talked about. Isaac, your background noise from if we talk about accuracy, the business meaning is that overall correctness of your model. Talk about precision, the business meaning is that to let you avoid false alarms. If you say recall, business meaning is that it catches important what? Case. And F1 score plans both precision and recall. So on this note, we'll bring today's session to an end. Thank you for your attention. Any questions so far?
No, sir.
Dr. Ahmed, are you around? I think he's dropped off. Yeah. Let me ask him whether he has some announcements. His line cannot be reached. So let's call it a day until we meet next week. If anything, I think he'll put it on the platform.
All right, thank you so much, sir. But I believe you're going to share the slides with us, sir.
I'll give you last week's on. Oh,
Thank you.
yeah.
Yes, sir. Right, sir.